Okay, so let's do some of this worksheet. I'll work on evens. So first begin by telling which type of reaction is taking place. Okay, so I'm going to go ahead and start with number 1 here. We have a compound. How do I know it's a compound? Because there's more than one element here. We have another compound. So when I see two compounds added together, I'm going to think that this is going to be a double displacement reaction or double replacement. Displacement, replacement, same thing. The more of these you do, the more that you're going to start noticing that stuff. And let's point it out. Right here, I'm going to identify my cations, and the cations are the positive ions. And then I'll go ahead and identify my anions, which are the negative ions. These particular ones happen to be polyatomic ions, which means they are an ion made of more than one atom. We're not really doing those, but you can, let me just show you how to work with it. You don't have to write names and stuff with those. So what I see here is that the calcium and aluminum have seemed to change places, or actually they're about the same. It looks like those have swapped places. So this is a double replacement or double displacement reaction. Okay, I always say displacement, so if you hear me say displacement, don't worry, I think your textbook says double replacement. That was in the notes too. Okay, so then the next question is, how do I balance this? So I don't have a lot of room here, so I'll just try to work with that. I'm going to separate, that black line was to separate the reactant side, so these are the reactants, and this is the product side over here. Okay, and all I've got to do is I've got to count everything. So I have calcium and aluminum, and like I said, I don't have a lot of space, so I'll color code it. We have hydroxide, and I'm going to put parentheses around it. I am not writing that I have two of those. I'm just counting what I actually have right there. And then also have sulfate. And you don't have to know the names of these. So over here I've got hydroxide and sulfate, and these should be the same on either side. If they're not the same on either side, then we have issues here. Okay, so I'm going to count. I am looking at the calciums. I have one calcium in the reactant and one calcium in the product. That 4 right there only applies to the oxygen. So we have one calcium and one calcium on either side. Then I count the aluminums on either side, and here I have a subscript of 2, which means I have 2 aluminums in the reactant, but I only have 1 aluminum in the product. And then as I count, I have this OH, it's called hydroxide, and this subscript outside of it says that I've got 2 of those. And on the left, the right, I mixed up left and right. On the product side, on the right, we have 3 hydroxides signified by that little subscript right there. Okay? And then for sulfate, this is fun. Sulfate is SO4. That's the polyatomic ion. Again, you do not have to know that. You don't have to know the names of those, but I want you to recognize what to do with this. Inside the parentheses, you can't touch, but there's a 3 outside the parentheses, and that 3 means I have 3 of those ions, 3 of the sulfates. On the product side, I have just the SO4, and you'll notice there's no parentheses because they're not technically needed, but I can put them in there if I want to. Actually, I want to do that in black. And you'll notice that I just have 1 of those SO4s, sulfates. Okay, so all I have done is I've kept track down here. I've kept track of how many of each thing that I have. And now I just have to balance. The only thing you're allowed to touch with balancing is coefficients. If you do anything other than coefficients, your GPA will drop 4 points. Seriously. Okay. So, I don't like the fact that there's 2 aluminums on the reactant side and 1 on the product side. So I've got 2 aluminums and I've got 1. So I'm going to put a coefficient here to turn this 1 into a 2. So I put a number out front. And I changed my aluminum, so now I have 2 aluminums. But I also changed the number of OHs, hydroxide. Okay, so I have 2 times the 3 that I already had. I have doubled what I already have. So now I actually have to change this to 6. And this is where you're like going, oh no, I messed up. Don't panic, okay? These problems, and I don't know why, but a double displacement being one of the first ones, they're the hardest ones. But these problems, it is very, very normal for you to say, oh my gosh, start over, I can't do it. That's okay. That's part of how you learn it. If you're not doing that, then be suspicious. If you're not having to start over once in a while, or, you may not erase the whole thing, you may just do it in your head, but if you're not starting over once in a while, be suspicious, okay? Okay, so now the question is, what's not balanced? Well, my aluminum is, my hydroxide is definitely not, sulfate is definitely not, calcium is, so we'll just play around. I'm kind of mad that we messed up the hydroxide. So let's change this by putting a 3. Why a 3? Because I had 2 hydroxides. That's the OH. And to make 6, I had to triple that. So let me clean this up. I now have 6 hydroxides. However, I just broke calcium. Okay? And now as you look at it, this is where you're probably going, yikes, I really, really don't like this. This is terrible. Don't worry. It frequently solves itself, as you're about to see. So I have 3 calciums and 1 calcium. That's not balanced. I have 3 of the SO4s, the sulfates, and I have 1 SO4. So I'm just going to balance the calcium by putting a 3 on the product side. What that did is I now have 3 calciums, but the 3 also applies to the sulfate, and now we have 3 sulfates. And if you look through carefully, we have 3 calcium, 2 aluminum, 2 aluminum, 6 OHs, hydroxide, 3 sulfates, 3 sulfates. This is now balanced. My coefficients are 3, 1, which you do not write, another 3, that line was separating my reactants and products, and then a 2. And we already talked about how this is a double replacement reaction. Okay? Now I'm going to go ahead and work through some more of the evens so that you can see them. And I'm going to be honest with you, I didn't make this worksheet. We got it from the internet. And this is a combustion reaction. I'll tell you how to know that. And combustion reactions are some of the hardest ones to balance. So why not watch me go through a hard one? This one is actually not all that hard. A combustion reaction has some sort of fuel, and the fuel is going to be a carbon and hydrogen combination. So there's my fuel, C2H4, and I recognized it because it reacts with oxygen, and combustion reactions always produce carbon dioxide and water. Okay? So easy to identify as a combustion reaction. more difficult to balance. That is not the tool I wanted. I wanted this. Combustion reaction. Okay, so what I'm going to do is I'm going to separate these out, and I'm going to do like I did before. I have carbon, hydrogen, and oxygen on both sides, and I'm going to simply count. I have 2 carbons, 4 hydrogen, and 2 oxygen on the reactant side. And over here I have 1 carbon, 2 hydrogens, and 3 oxygens here. Pause it a minute and make sure that you saw 3 oxygens. That is the number 1 mistake made of combustion reactions. Okay, did you find it? We have 2 oxygens here and 1 oxygen here. That makes 13. So all I have to do to balance is identify what needs fixing. I have carbon needs fixing, I have hydrogen needs fixing, and okay, we got to fix everything. Little hint. The fact that this is an odd number over here means it's never going to balance with this even number over here. So turning this into the total into an even number will allow me to eventually balance it. Another hint. Anytime you see something by itself, you can throw any whole number there and it'll balance. So save this for last. So I am personally going to try to make the oxygen on the product side even. So I'm just going to throw a random 2 here. And what that did is I now have 2 oxygens plus 2 more oxygens. I have 4 oxygens. And I also happen to, I balanced hydrogen. That's kind of nice. So what I've got now is something a whole lot easier to work with because I have an even number and an even number. There's nothing I can multiply, because this is 2 oxygens here, there's nothing I can multiply this by to get an odd number. So I had to make it even. The only thing that needs fixing is carbon. So I'm going to throw a 2 here, and I now have my 2 carbon. However, pause it and see if you saw it. Did you see it? I have 4 oxygen plus 2 oxygen. I now have 6 oxygen. And you're saying, oh no, we messed it up. Don't worry. Check it out. I said that this is easy to fix. We have 2 over here and we have 6 over here. If I multiply this by 3, I now have 6 oxygen. And now check every single thing out. It's balanced. My coefficients are 1, 3, 2, and 2. Okay? Like I said, double displacement and combustion are the hard ones. So we'll get a little bit better here. I'll do number 6. Type of reaction for number 6. I have a compound. I have an element, and it is written as I2 because that's the way it's found in nature. That is nothing that you have to know. Also, the hydrogen. In chemistry, you have to memorize the 7 elements that are always written this way. We're going to write them for you, so don't worry about that. Okay? So we have a compound plus an element yields a compound plus an element. That is a single displacement or single replacement reaction. So we are going to tally everything again. We have nitrogen, hydrogen, and iodine. And we have nitrogen, hydrogen, and iodine. Okay. We have 1 nitrogen, 3 hydrogens, 2 iodines. We have 2 nitrogens, 6 iodines, 2 hydrogens. And you're going, oh, I don't like this at all. Keep that hint in mind. Here's something by itself. Here's something by itself. Save them for last. Nitrogen is going to need some fixing. So let's throw a 2 here, which means I have 2 nitrogens now. But now I have 6 hydrogens. Okay? And as we look through this, the only thing that needs fixing is now the hydrogen and iodine, and those are the ones by itself. So I want to have, I've got 2 iodines and 6 iodines. So what do I multiply 2 by to get 6? Multiply it by 3, and now we have 6 iodines. I also have, where is it? 6 hydrogens, but I've only got 2 here, so I'm going to multiply this by 3, and now I have 6 hydrogens, and this is balanced. My coefficients are 2, 3, 1, and 3. Remember, you don't actually write the 1. Okay, so let's do some just practicing balancing equations here. Okay. I'm going to go through these a little bit faster, and you can check your answers there. So I'm going to take a little less time to explain, but all I'm going to do is count. Well, if I can do it properly. I'm going to count everything in here. And I'm going to write it the same. Actually, you know what? I want to write it the exact same way I have it over on the left so I don't get confused. I've got 1 silver, 2 silvers, 1 iodine, 3 iodines, 1, 1, 3. That 3 says I have 3 of the CO3s. And then 1. Okay. Where to begin? I don't know. Just pick something is typically the way it is. Okay, so I threw a 3 there because I was trying to make this a 3. Remember, there's only 1 of those, and 3 times that 1 is 3. So I was trying to do that, but that messed up my silver. So I'm just going to go back over here and fix silver because, hey, that's easy. 6 and 6. Now I really have iodine messed up big time. So I have 6 iodine on the reactants and 3 on the product. So I'm going to multiply that by a 2 so I can get 6 iodines, but that messed up my iron to 2. And, oh, I have a mistake. When I was counting the number of irons on the reactant, I wrote a 1. I should have written a 2. So I actually made a mistake. If I hadn't caught that, I would not have been able to finish this problem. Okay. As I look over it, it looks like everything is matched. We now have a balanced equation. 6, 1, 2, and 3. Okay, let me do another even. So I'll do number 4. And I'm going to go through it fast again. I have zinc, sulfate, which is the SO4, lithium, and carbonate. And the way that you're going to recognize these is you're going to have a cation and an anion. These are going to be the metals here. Notice these are all ionic. Well, most of them are ionic compounds, but if I've got with the double displacement, you're going to have, those are always ionic. You're going to have a metal and a non-metal. You're going to have the cation and anion. So you can recognize, hey, those metals by themselves are different. Everything after must be one of those pesky polyatomic ions you keep telling me about that you don't have to worry so much about. So we have 1, 2, where am I? 2, 1. And guess what? This is balanced. My coefficients are 1, 1, 1, 1. Okay. Number 6, well, we're doing nothing but double displacement reactions. We have magnesium, that's a metal. We have beryllium, that's a metal. And yes, I did them a little bit different than last time. Just trying to show that there are, oh, did I say magnesium? That's manganese. Magnesium is Mg. Just trying to show that there are multiple ways of doing this. Chemistry is about trying to figure things out and not necessarily being told exactly how, although the nice thing with chemistry is there are procedures you can do to be told exactly how if you're having trouble with it. Okay, we have beryllium. Ooh, is this going to be already balanced? It is. Huh. Well, it just gets easier and easier, doesn't it? This one's already balanced. Let's try number 8. No, I didn't try these out ahead of time and pick the ones that are already balanced. How dare you think that of me? Okay, this one gets a little strange. We have a hydrogen, but then you notice over here water. That's not an ionic compound. Well, that's okay. Hydrogen acts like a metal sometimes, and this is one of those cases where it does. SO4OH. So I've got two hydrogens, one boron, one sulfate, 3 sulfates, 3 hydroxides. Okay, and now you're going, dude, there's no hydroxide. Okay. This is a weird one. When you see these, you can write HOH. That's another way of writing water, which means, well, that was weird. Okay, which means I got to fix this hydrogen because I'm only going to count that one. So I'm going to make this 1 hydrogen and 1 hydroxide. How are you supposed to know that? It's just a little trick. If you are balancing equations and you see H2O, you may change it to HOH because it makes it easier to balance. Hydrogen, hydroxide. No big deal. Okay, so hydrogen is not balanced, so I'm going to throw a 2 here to balance this again, which means I have 2 hydrogens and 2 hydroxides. And then I look over here and I go, oh no, who is that, Baymax? I have an odd number of hydroxides and I have an even number. So I'm going to double this, and now we have 2 borons, and we have 6 hydroxides. And you're going, you're getting worse, Lanham. No, I made them even. I have an even number of hydroxide, even number of hydroxide. Instead of multiplying by 2, I'm going to multiply by a 6. So I'm going to change this 2 into a 6. This is getting messy. Change the 2 into a 6. I now have, this is, like I said, getting messy. I have 6 hydrogens. Follow along, and I have 6 hydroxides. And now we're still not there. We have 2 hydrogens, and where'd hydrogen go? And 6 hydrogens. We have 1 sulfate and 3 sulfates, and hopefully you saw 3 times 2 is 6. So we're going to turn this into a 3. So we now have 6 hydrogen, and we have 3 times one of those sulfates is 3. And we have balanced that one. Okay, number 10. Oh, look at all this beautiful space. This will be so much easier. We have iron, silver, and nitrate. Iron, silver, and nitrate. Okay, make that better. We have metals that have swapped places. This is a single displacement reaction. I've got 1 and 1, 1 and 1, 1 and 2. I have 1 of the nitrates and I have 2 of the nitrates. That's why I just said that. So I'm going to double this so we have twice as much nitrate, but I now have twice as much silver. So I better throw 2 out here to balance the silver, and we are good. Hydrogen. Uh-oh. Okay, so let's keep balancing here. I'll just keep doing the evens. Okay, looks like this page is a little bit easier. We have iron, palladium. Okay, there's just not enough room on here. So I'll spread it out. We have iron, oxygen, palladium. That's the PD and the F. And then I want to write them in the same order, just because it makes it easier to count. Okay, so I've got 1 iron, 1 oxygen, 1 palladium, 2 fluorines, 1 oxygen, 2 fluorine. Did I say oxygen? Iron. 1 iron, 2 fluorines, 1 oxygen, 1 palladium. Another balanced one. Hope I'm not taking all the balanced ones from y'all. The other, number 4, another even. Lithium chloride bromine. Lithium chloride bromine. We have 1, 1, 2, 1, 2, 1. Okay, so definitely not balanced. The chlorine and bromium. Alright, so if I throw this to fix bromium, I've now messed up lithium, but that fixed everything. So that one is now balanced. Number 6, we have cobalt, bromium, calcium, and sulfate. Put that below the arrow. Write it the same way. Calcium, bromine. What do I have? Oh, nope. I was saying, why do I have 2 calciums? That's cobalt. Bromine. Neat handwriting helps in chemistry, which is one of my weak points. 1 cobalt, 2 cobalts, 3 bromines, 2 bromines. There's an odd-even situation that'll be easy to remedy. 1 calcium, 3 sulfates. I didn't leave myself room for the sulfates, so I just put a 1 underneath it there. Okay, so like I said, we've got an odd-even situation with bromine. I've got 3 here and 2 here, so I am going to fix this first. So now I have 2 cobalts and 6 bromines. And then to turn that into 6 bromines, I'm going to put a 3. And now I've got 6 bromines and 3 calciums. Okay, bromine is balanced. Not much else is. I do see that I've got 3 calciums in the reactant and only 1 in the product. That sounds pretty easy to fix. So I've got 3 calciums, but I also changed that to 3 sulfate, and that automatically fixed the sulfate. So that one is balanced. That one may be one that you run around a few times and do. We have manganese, hydrogen, iodine. Manganese, hydrogen, iodine. 1, 1, 1, 1, 2, 3. I see that 3. I said something about doubling, but this I is by itself, so I can just put a 3 in front of that, and that's fine. In fact, let's just see what that does. So I would have 3 hydrogens and 3 iodines. Now there's a problem. There is nothing to multiply this by, this hydrogen, to get 3 hydrogens. So I'm going to double that. I'm going to turn this into a 6. And that means if I put a 3 here, I've got the right number of hydrogens. And now you're going, Lanham, dude, you just messed up iodine. I know. Let's put a 2 out front here. And now we'll also have 6 iodines, but we have 2 manganese. Better fix it with that. Okay. Alright, let's try a little bit here. Probably cut at this spot since I can do this. Okay. Back. Number 10, we have a double displacement because I see compound on one side, and then I want to write them the same way. Yes, even though what I'm writing is not in the same order on the right side, the product side, it just makes it easier to spot it when I'm trying to double check all of my answers. Maybe not when I'm counting initially, but it makes the end go smoother. I did it again. I didn't leave any room for the sulfate, so I'm going to have to record a 1 down below. I apologize. It'll get a little messy there. And 1. Ooh, is it all balanced? Of course not. Fluorine and lithium are not balanced. Oh, but that's easy. Is that it? Yay, that's it. Okay. 12, we have another compound plus compound, so this is double displacement. Try and leave myself more room. Calcium, bromine, and then I'll put the black line a little further so I give myself room. Lithium, nitrate, calcium, bromine. Counting, 1 lithium, 1 lithium, 1 nitrate, 2 nitrates. Definitely not balanced. Okay, so let's try fixing nitrate. Why? Why not? You literally just have to guess stuff here, and you can't watch. You have to get your fingers dirty when you're doing this stuff. Okay, and actually that one turns out to be pretty easy. Double check everything. What I'm doing when I'm double checking, when you hear me pause, I've got 2 lithiums, 2 lithiums, 2 nitrates, 2 nitrates, 1 calcium, 1 calcium, 2 bromines, 2 bromines, and we are good. Okay, let's do some of these word equations. Now these are going to be a little bit different. You have to write the formula first, and then you write the equation. Now, some of the things in this are things that we have not taught you yet. Nitrate is a polyatomic ion. I'll give you that. You don't know the formula for isopropanol, but we told you that. There's a little trick about oxygen. There's a little trick with, I just saw it further down, fluorine gas. So I'll write those down for you so that you can do this worksheet. Yeah, and those are things that you would have to know next year in chemistry. I'm just going to give them to you now, so definitely don't worry about it. So let me do... I was going to do number 1, but let me do this for you. Nitrate, has a formula of NO2, and its oxidation is -1. And in chemistry, we actually have what's called a polyatomic ion chart where you look this up. And I am 99% sure that's right, but just to make sure. Hey Siri, what is the formula for nitrate? NO3. I was wrong. So, yeah. NO3, and the charge is -1. Nitrite is NO2. Okay. So when you're writing this, silver nitrate would be Ag with the +1. That is technically a transition metal, but that's one of those that in chemistry they have to know. And then NO3 negative 1 means our formula is just one of each. So silver nitrate is that. Actually, silver nitrate is that formula right there. Okay. Fluorine gas is going to be an F2, not an F. So when you're doing the worksheet, make sure you do those. Okay. There's some other odd things like aqueous, that just means dissolved in water. There's nothing, don't worry about doing that. The fact that it's a powder doesn't mean anything. The fact that it's exothermic doesn't mean anything. So those don't have anything, well, they mean something, but they don't have anything to do with the balancing equations. So I've been doing evens, and the second one here is one of the harder ones, so I'll go ahead and do it. It says when this burns in oxygen. So the formula is, is C3H8O. Burns in oxygen means reacts with. And oxygen is one of those that's O2, not O. Again, that's chemistry for next year. You don't have to do that. And it's going to, it says carbon dioxide, water, and heat are produced. So these are the products. And whenever you see produces carbon dioxide and water, you should be saying combustion. Wow, I wrote that nice and big and didn't leave myself anywhere to go. Sometimes you just need a lot of space when you're doing these. Okay. I just put H2O and carbon dioxide, but it doesn't matter there. That's not an eraser. Oh, now I can't erase the plus. Fine, whatever. Okay. We have carbon, hydrogen, and oxygen. And we have 3 over here, 8 here, and 3 here. Did you catch that? If not, pause it. Did you catch it? We have 1 oxygen here, 2 oxygens there. Over here I've got 1 carbon, 2 hydrogen, and 3 oxygen. Did you catch it? Go back and check. Okay, I want to fix carbon or hydrogen because the oxygen is done. Why does my oxygen look like a C? That could cause problems later. Like I said, writing neatly is good. That's one of my downsides. Okay, I'm going to change this to 3 carbons, but now I have 7 oxygens. Oxygen. Did you catch why that's 7? Because we have 3. We have tripled those 2, so that's 6 plus 1 is 7. Let's clean that up and just double our oxygen. I only did that just to clean it up a little bit. I have an odd number of oxygen over here, so I'm going to change that to a 2. Wow, this just messes everything up. Did I tell you that the combustion ones are the hardest to do? Okay. That actually looks nice to me because I've got all even... No, I don't have even numbers. The carbon over there is... Alright, let's make this 6. 6, so we have 2 plus 12 is 14 oxygen. And you're going, oh, this is scary, this is bad. See that oxygen by itself? That'll be the easiest thing to do. So we're going to leave that one alone. Don't worry, the combustion ones are the hardest, but we're not going to do as many of those. So what would I like to fix? Carbon is nice, hydrogen is not. So if I have 16 here, I really want to have this as an 8. So now I've got 16 hydrogen, but I have 8 plus 12 oxygen is now 20 oxygen. So according to this, carbon is balanced, hydrogen is balanced, oxygen is 2 and 20, which makes it really easy. I'm going to put a 10 out front and turn this into a 20. Let me clean that up. So we have 2 C3H8Os plus 10 oxygens. This is where you might want to do the little line through your 0 so you don't confuse those. And then we have 8 H2Os plus 6 CO2s. And that is balanced with one issue. These are all even numbers. We have to reduce to 1, 5, 4, and 6. And we don't write the 1. So my official balanced equation is the reduced version. Question: do you have to reduce? Yes. If you don't reduce, you lose only 2 points off your GPA. Oops, I didn't reduce that. That's a 3. It's hard to talk and write. 3 CO2s. Let's stay consistent. Okay? So this would be my balanced equation for that word equation. Okay? And yes, this is what chemists do. And honestly, the more they practice, the easier it gets. Eventually they can do it in their head and stuff like that. I'll do number 4. We have fluorine gas, F2, with contact with calcium metal. So in other words, it reacts with calcium metal. We have calcium fluoride created. That's it. It's just calcium fluoride. I need to know the formula for calcium fluoride. It is a metal to nonmetal, so it is an ionic compound. If I look at the periodic table, calcium is 2+, fluoride is -1. So this is my formula right here. You have to have the correct formula or it will not work. And this is balanced. So some of them are like that. What I want you to do now is go back and hopefully you have worked this out with me while I'm doing it and paused it and thought about it. But go back and do the ones that I have not done for practice.